What's up everybody, welcome back. So we're gonna keep working on our car today and we're slowly getting into the little bit more interesting behavior stuff. Although I don't think we're gonna actually make the behavior tree and the blackboard setup in this episode. We'll probably get to that in the next episode. But we are going to start the setup for different states of our AI. And I need to do a little bit of explaining to make that a little bit easier to understand. So first of all, if you make a project like this, you want to come up with certain rules at the beginning of what needs to happen if an AI sees you, when he needs to go in combat, things like that. So you have clear rules of where you need to work to, and if you come up with those things on the fly, it's a lot harder to do. So I've set up a few rules that we're going to use, and I'm going to go over those quickly. So as I mentioned, the AI is going to have different states. He's going to have the idle state, where he is in now, so he's simply standing around looking for enemies. And then he also has an aware state and a combat state, and later in the series we're also going to add searching state. So the aware state is simply where he hears or sees us, and he's going to investigate that location. So from an aware state, he can also go back into an idle state if he doesn't find an enemy. So those can be swapped out. Then if we are in an aware state and we actually find an enemy, we will go into combat. And the combat state is non-reversible. So as soon as we enter combat, it's done. There's no going back to searching or aware or idle. Once we're fighting, we are fighting till the death. So that's a pretty important thing that we need to take care of, so we can use that. It's going to be kind of a hard cutoff point in our behavior. The combat behavior is going to be separate from all the behavior before that, so we can kind of say, okay, at this point the AI goes into combat, we can trigger that, and then we can go back later to set up the actual combat behavior. So that's what we're going to do today. We're going to set up the different states for the AI, and we're probably also going to set up the actual triggering of the combat state, so we know when that state triggers and when things will change. So that's what we're going to do today. If you like the series, please consider leaving a like, and if you want to get the project files for a download, you can become a YouTube member or a Patreon, and then you will get access to premium channels in the Discord and also downloads for this project. So with all of that stuff out of the way, let's start today's video. First of all, let's set up our combat state and the actual triggering of it, so we know where our cutoff point is and when we can start worrying about our previous behavior. So we're gonna need to add something in our player AI component. So let's start there. We're gonna go to the blueprints folder and open the player AI component. So this is the component that we're going to add to the player's character if we want to migrate this to another project, for example. So in here, we're going to create an event that we can trigger if we start combat. So the player also knows the combat started. So let's simply call this start combat. And what we want to do is simply remove all of the widgets from all of the AI that are perceiving the player and have their progress bar filling, for example, or the exclamation mark icons. So we want to get rid of all of that stuff. So for the start combat state, we're going to set it to run on the owning client. And then we're going to grab all of our perceiving actors and simply loop through them. So these are all the actors that are spotting us. And then for those, we can call an interface event to remove the widget component. So we can drag off the array element and call our interface function to remove the widget component. And the target is actually the widget that we need to assign. So we can grab the progress bar widget components over here. So sorry, not progress bar, but the widget components. The progress bar are the actual widgets. And from here we can get the same index from the array as we are getting from the perceiving actors. That should be the correct component, so we can plug that in over here. And that should destroy the component. And after we removed all of the components, we can simply clear all of the arrays. So we're probably not going to use those anymore in the combat state. So from the completed pin, simply hook up all three of them and hook up a clear node. No, that's a map. And we actually want to clear an array. And we need to do that 3 times. So that's everything we are going to do for now for the player, but we also have a hook in place where we can simply add logic if we want to start combat. So let's compile and save. That's the character setup for now. Now let's take a look at the actual AI setup, and we're going to be using an interface for that. And we already made that. So let's go to the behavior folder, and we have our AI pawn interface. So this is the one that goes on the actual AI character. We're going to add a function in here and call this start combat as well. We might want to call it AI start combat, so we have a different name. So let's do that. And we have implemented this function. So let's save and close the interface so we can set it up in our pawn. But before we do that, we're also going to create the actual state, and that's going to be an enumeration. So also in the behavior folder, I'm going to right click and go to blueprints, and we're going to use an enumeration for the states. So create one, and let's call this enumeration AI states, for example. So I'm going to start by adding 3 of them. We're going to add the idle state, we're going to add the aware state and the combat state. And as I mentioned later in the series, we're also going to add the searching state, but we can add that later. So idle, combat and aware. Let's save it and close this down as well. And now we can dive into our AI controller. So we want to open the AI controller over here. And the first thing we're going to do is add the actual state inside of the AI controller as well as a variable. So simply create a variable, and let's call this our current state. And we're going to change it into the AI state enumeration that we just created. So if we compile, by default it's on idle, so that's nice. Now we also need to set up something in here. So let me grab my notes quickly. We're going to implement the, let me double check. So the start combat state that we can call from the pawn if the combat actually started. So let's create a custom event, and we're going to call this start combat state. So we don't need to replicate any of this on the AI because all of this is server side. So first of all, we're going to grab our current state and we're going to set it to combat, just like this. And then we want to grab our possessed pawn. And we can call the interface function that we just created on the interface. So that's AI start combat. Over here. So the pawn also knows the combat started. And then we can pretty much clear our timer for the awareness loop because we don't need to worry about that stuff anymore. So let's check if we have a valid timer running or not. And if we do, we're simply going to clear and invalidate the timer. So let's hook up a branch here. And if we have a valid timer, so if it's true, we're going to clear and invalidate. And hook it up like so. So this will make sure our perception loop event will stop looping. Okay, so that's good to go. Now we can open up the actual character, so the AI guard. And I accidentally closed that one in my example project, so let me grab that quickly and open it up here as well. So in here we want to implement the actual interface, I assume. So let me quickly get to the correct point in my notes. Yes. So we're going to implement the interface event. So let's double click it to create it, AI start combat. And in here, for now, we're simply going to turn the enemy into a different color so we can see the combat started. And we're not going to do anything else at this point. So if we want to change a material, we need to do it on all instances of the character. This is something that's not replicated. It's visual, just like playing an animation or playing an FX or a sound. So all of that stuff, you need to replicate that yourself. So we're going to simply use a multicast event because this is temporary anyway. if this would be something that we would actually use later, then we probably would use rep notify. But in this case, we're going to create a custom event, and we're going to call this multicast set material. So we need to set it up as a multicast event for the replication, and then we can call that over here. So multicast set material. And all I want to do in here is grab the character mesh, and we're going to set a material. So simply this one, and for this one we can specify an index and a material. So if we select the mesh over here, we have two indexes. Element 0 is for the body material, element 1 is only the logo. So I'm simply only going to do the body one. And we probably want to give that a little bit of a different color. So what I simply did was go into the level prototyping materials folder and duplicate this solid blue material. So let's call this solid red, for example. Open it up and then change the color in here. So we have a nice red material, and then for the guard I'm simply gonna make his body red so we know he's in combat. So assign the red material and change element index 0. Okay, so that should be the setup for the pawn for now. And now we need to link all of this together. So we're going to create a component that we can add to the game mode to actually trigger combat on all of the pawns and the player characters. So because we want to try and keep this a little bit modular, we're going to create a component again. So let's go to the blueprints folder, right click, blueprint class, and we're going to select an actor component. So let's call this something like our blueprint game mode AI component. And we want to set up a small event in here. So let's open it up. So we're simply going to add a start combat event in here that we can call, and that will distribute the start combat calls to all of the AI and the players in the game. So let's create a custom event and let's call this start combat as well. So the first thing we want to do is tell all of the AI that we actually went into combat. So we can drag off here and get all actors of class. And we want to get all of the AI controllers. So we can simply look for GDR AI controller. And we will get an array of all of those. So we can simply add a for each loop over here. Loop through the array, and for the array we can call our start combat state function over here and plug that into the loop body. And we also want to tell all of the players in the game that the combat started, so they can remove all of the widgets from the AI, from the side perception bars and things like that. But we need a reference to all of our players. And in a normal game mode, we would have something like event handle starting new player, so we can actually collect all of the connecting controllers and keep an array of them. But since this is not actually a game mode, that's not in here, so we need to come up with a solution. For now, we're simply going to create a variable and call this all player components. So we're going to turn this into the player AI component. And also turn it into an array. Now over here we can grab another for each loop, hook it up to the completed pin, and we're going to loop through all of our player components and also tell those that the combat started. So call start combat over here. And now we need to make sure that this array will actually be populated, so we can compile and save our Gamemode component, and we need to go back to our player AI component. So this is the component that we actually want to store inside of these arrays. So we can simply add an event begin play on here. And because this is a player component, so it's actually on the character side, we want to make sure that we are on the server instance. So we're going to grab a branch in here and check if we are the server, is server. And if we are going to register ourselves with the game mode component. So we want to get the game mode. And from the game mode, we can drag off and get a component by class. Component or components, that doesn't really matter. We only have one component of this class on the game mode anyway, so I'm gonna grab this one. And we want to get the Gamemode AI component that we just created. And now that we have a reference to that component, we can drag off here and get the array with all of the player components and simply add ourselves to that array. So drag off here and look for an add node. So we want to plug this one into the true pin over here. And then we simply want to add a reference to ourselves, like so. So this will make sure if this AI controller, this player component gets created, begin play fires, and he will register himself with the game mode component. So that's good to go as well. Now we do need to make sure that we actually add the component to our game mode. So let's go to our third person blueprints folder. So we're still using the third person game mode. So let's open this one up. And we need to go to the full blueprint editor, and then we can add a component in here. So let's add one, and that's going to be our AI component, so the game mode AI component. And simply add it over here. Compile and save, and that's good to go. Okay, so we have the basic for that setup. Now we can actually set up the trigger for the combat behavior on the AI controller. Let's open up the AI controller again. And in here, we want to go to our awareness loop function over here, or event actually. And we want to change and add some stuff in here. So I'm going to make sure we have a little bit of room. Let me move this event out of the way and move it down a little. Like so. The first thing we're going to do is make sure that we don't actually continue all of this logic if we trigger the combat state. So for the loop body inside of the reversed for each loop, we're going to add a switch for our enumeration. So we're going to drag off here and switch on our AI states array, enumeration, sorry. And we can plug in the current state of the AI as the selection over here. So if we are idle, we want to continue to the branch and update our actual perception. If we are in combat, we don't want to do anything at it, in this event. So we're simply not going to hook anything up over here. And then at the end, if we follow the completed pin, we also want to change up this condition. So if over here combat is triggered, we also want to stop the awareness loop. So let's disconnect this, and we're going to add an OR boolean. And in this case, we can simply hook up the current state of this AI and check if it's combat or not. So we can drag off here, do equal enum. So the top one over here, and then simply select combat state in the drop-down list and plug it in and make sure you hook up the condition again. So this will make sure the timer will also stop looping if we trigger combat in here. Now we are going to make it that if we enter a certain side range inside of the AI, the combat will automatically trigger. So right now, if we walk into the side range, we will get the little sidebar. And that's okay, but at some point it doesn't really make sense if I'm standing here and the sidebar is simply increasing. At a certain range, I feel like combat should just trigger immediately. So I'm going to add a minimum range in here, and if we enter that range, or if the AI sees us inside of that range, we will instantly go into combat. So that's what we're going to do inside of the awareness loop over here. And we actually want to do that before we check all of the perceived actors' times. So we're going to disconnect the reversed for each loop. And we're going to add a for each loop with break in front of here. So we're going to grab all of our perceived actors again. And this time we want to for each loop with break. So we can hook it up to the event, and then for the completed pin, we're going to go back to the reversed for each loop. So first of all, we're going to do this part. And what we want to do in here, first of all, we need to know if we actually perceive this actor successfully or not. So we can grab our perceived successfully bools, get a copy of the correct index in here, and simply check the value. So let's hook up a branch and make sure this is true. Like so. And then we want to know the distance between those actors to determine if we're going to trigger combat or not. So we can drag off the array element, that's the player that has been perceived, and we can get the distance. And in this case, we're going to use the squared distance. And the only reason for that is because it's lighter to work with. And this is going to run in a loop every 0.2 seconds or so. So we're going to execute this quite a lot. And we're not using a squared root if we want to calculate squared distance. And if we actually calculate distance, we need to use a square root, and that's a little bit more intensive. So I'm simply going to use the get squared horizontal, get squared distance to. That's the one we want. So the upper one here. And then we can simply plug into actors. So the other actor is the AI pawn. So that's the possessed pawn from the variables over here. Plug it in. And we need to compare this. So we're going to hook it up to a branch. Hook this one up to the true pin. And now we need to come up with a certain range. So let's say this is less than or equal to. That's going to be the condition. And because we're using a squared distance, we might want to just use a multiply node to actually enter the values. So that's a little bit easier. So we're going to drag over here to multiply. And then promote this to a variable. And that's our close side range. So promote to variable, close side range. Close. Let's make sure the spelling is correct. There we go. And we can hook them up to both over here. So that will make it squared again. And we can set a default. So in my example project, I have this set to 650 units. So we can play around with this. And also to test, we might want to change it later. But let's start with 650 and see what happens. So if we're actually inside of this range, we're going to trigger combat. So we can drag off here and we can call our AI change. No, we can't do that because we didn't create that yet. So we can simply call our start combat state on the actual, what's this? The AI controller for now. But this will only make sure that this AI goes into combat, and we need to make sure that all of the AIs goes into combat. So later we need to change this up a little bit, but for now, let's hook it up like this. And because we triggered combat, we want to break the loop. Nope. So there's nothing else that is going to happen in here anymore. Once combat started, it's on. So there's no need to check any other actor. So that's hooked up and good to go as well. And if we don't have any actors inside of our close side range, we're simply going to continue to the reversed for each loop and continue counting for the progress bars. Okay, so if we compile and save, we should be able to test this quickly. And if we go inside of the close side range, the AI should turn red. And we should have the actual progress bar disappear. So that's not working. And we might want to check out why that is. So I'm going to get back in a second. Okay, that's not really true. We're calling the start combat event over here and not the actual event on the game mode. So for that reason, at this point, the widget will not disappear, but we are actually triggering the combat state. So that's good enough for now. And we can actually set up the rest. So we're just going to continue. And at the end of the episode, this should work. So we want to continue working inside of the AI controller, and we're going to set up the event to change the states that we want to call in here. So let's create a new custom event. And we're going to call this AI change state. So we're going to give this one input, and that's the new state. So this is going to be our AI states enumeration, like so. And then later we also want to be able to pass on an actor. So we're going to add the input right away, and that's going to be the spotted actor. And that's simply an actor reference. So change it into a normal actor over here. So we want to change the state. First of all, let's check our current state. Oh, my mouse is freaking out. So we can drag off the current state in here and switch on it, like so. Plug it in. So if we are currently idle, we need to check what state we want to switch to. So we can drag off the new state and switch again, like so. Plug it into the idle pin. If we are idle, we cannot switch to idle. That doesn't make sense, so we don't need to hook anything up here. If we are aware, then we need to start our searching state, so we can do that later. For now, we want to worry about the combat state. And we want to trigger the combat event on the game mode. So we're going to make sure this stuff runs on the server side, so we can actually access the game mode from there. So at this point, we can simply get the game mode. From the game mode, we want to get a component by class again. And we're going to grab our Gamemode AI component. So Gamemode AI component over here. And from there, we can call our start combat event. So the normal one, not the message one. And we can hook this up to the combat pin. So if we want to go from idle to combat, that's a valid transition and we can trigger start combat. So if we are in the aware state, then we also want to check what states we want to switch to. So we're going to drag off again and switch on the states. So if we are aware and we want to go back to idle, we can. So we can set that up later. If we are aware, we cannot trigger aware again, so we don't need to hook up anything in here. And for the combat state, we can actually enter that from aware. So we're going to hook that up to the start combat as well. And that should work. So we're going to expand this event later. But for now, we have it set up and good to go. So we can go back into our awareness loop function over here. So this is the for each loop with break, where we check the close side range, and in here we want to change this call for the AI change state event that we just created. And we're going to change the state to combat, so we don't need to hook up a spotted actor. That's only if we want to trigger the aware state later. So this is good to go. And we want to do the same thing inside of our Gamemode component. Let me see. No, we don't want to do that actually. We want to go to our AI controller where we are at this point, and we need to expand this a little bit. So we're going to set up the awareness state as well and the triggering for that. So let me see. Let's create an event for the aware state first. So let's right click, create a custom event, and we're going to call this start aware state. So we're not actually going to do a whole lot of setup for the states. We simply want to make sure that we can trigger them at the correct points and with the correct conditions. So for the start aware state, we also want to add an input, and that's our spotted actor again. So that's an actor reference. And the first thing we want to do in here is change the actual state. So we're going to set the state to aware. And then we need to get the last perceived location of this actor that we want to investigate. So the aware state is when I fire my weapon or when my perception bar fills up, and the AI will actually start investigating that location. So that's what we're going to set up right now. And we need to make sure that it actually grabs the last perceived stimuli from this actor, and unfortunately they are not sorted by age on the perception component, but they are sorted by stimuli class. So to make sure that we get the correct last perceived perception, we're going to create a function for that and call this get last perceived location. And we want to pass on the actor in here, so that's the spotted actor. Like so, and we want to give a location as an output, so that's the location the AI needs to go and investigate. So location, and turn it into a vector. So for this function, first of all, let's make sure that we have the shortest age as a variable, so we can determine if the actual stimuli is older or newer. So we're going to create a new variable, call this local shortest age maybe, and that's a float. So the first thing I want to do in here is drag it in and set it to -1, so it's a invalid value. Then we want to get our AI perception component. We can drag off here and get the actor's perception. So the upper one over here. And as you can see, this will retrieve all of the previous sensed information about this actor. So plug it in over here. We need to plug in the spotted actor as the actor. And then we can drag off here and break the array. Break the structure, and we will get an array with the last sensed stimuli, and that's what we're after. So we want to grab a for each loop in here. Thank you. Plug it in, and we're going to plug in our last sensed stimuli so we can loop through them. Now we want to make sure that we only check for the sight and the hearing sense. So we're going to drag off the array element and get the sense class for this stimuli. Hook it up to the loop body. Drag off here again, and we can compare that. So do equal to. And we want to know if this is from the sight perception, so AI sense sight, or from the hearing perception. So we can copy and paste it, plug it in here again, and then change it into hearing. AI sense hearing. So we need to hook this up with an OR boolean. So if any of these two are true, that's okay. And hook it up to a branch over here. So if this is true, then we want to check the age of this stimuli. So we can drag off the array element again. No. Oh, my mouse is really annoying. I have a different mouse pad and it's not really working out. Unfortunately, my other mouse pad is at home and I'm not, so I need to deal with it. So we're going to break the stimuli structure over here, and we have the age of this particular stimuli. So we want to check if this age is smaller than our current age. First of all, we're going to check if we already have an age set up or not. So we're going to drag in a branch in here, and we're going to check our shortest age. So drag it in and compare it. So if this is equal to -1, then we actually can set it without checking. And the reason we're not simply checking if this is index 0 is because that might not be a sight sense or a hearing sense. So if this is -1, we don't need to worry about the actual age. We're simply going to grab our shortest age and set it to the age of this stimuli. And if we already did this previously, then we're going to check if the current stimuli is shorter or less than the age that we already have stored. And if it is, we're going to replace it. So we do need to keep track of the actual index that has the shortest age. So we need a variable for that one as well. The local shortest age index. Shortest age index. Oh, I'm hitting caps lock. There we go. So this is an integer. And then over here, we can set it. And plug in the array element. So we have a benchmark basically, and then we're going to simply check all of the other ones against that value. So drag it in. If the current age is less than our previous shortest edge, then this is going to be our shortest edge. So plug it in here, compare it to the shortest edge. If this is true, then we're going to set the shortest edge to this edge. Oh, freaking really. There we go. And we also want to update the index, so we have the correct index stored as well. So hook that up to the array element. And if this age is actually the same or longer, we don't want to do anything, so that's good to go. So when this loop is completed, we should have the index with the shortest age stored. So we can simply return that. So we can grab our return node over here, hook it up to the completed pin, and then we can drag off the array with the last sensed stimuli. Oh, come on. And I'm sorry. And we can get a copy. If I can find my return node again, there we go. So we can get a copy of the shortest age index, and then we can simply drag off here and break it. And in here is the location that we want to investigate. So that's the stimuli location. Plug it in here. Okay, so that's good to go. Now this function will return the last perceived location, and we want to go and investigate that. So let's drag in the function, plug it in, plug in our spotted actor. And then for now, I'm going to add one simple AI move to node. This is actually the point where we're going to move to our behavior tree and do all of the behavior stuff in there. So this AI move to node is really temporary. It's just for now to quickly make sure this is working. So we're going to do AI move to. The pawn is our possessed pawn, so we can plug that in over here. The destination is the location over here, and then we should be good to go. Yeah, we don't need to hook up anything else in here. So we have the start aware state, and we want to make sure that we actually call this event if we go from idle to aware. So if we go to the change state over here, if we go from idle to aware, that's this pin, we want to call our start aware state. And for the actual awareness, we need to plug in the spotted actor. So we're going to hook that up to the event, and we can grab the correct stimuli location. Okay, so that's the state for awareness. And now let's see what we're going to do next. We're going to make sure the state actually triggers when our perception sidebar fills. And we're also going to make sure that the sidebar disappears, so we can replace it with the exclamation mark icon later. And so for this start aware state, we want to go into the awareness loop, and then the lower part with the reversed for each loop. So we added the switch in here, and we want to make sure that if we are aware, that we get rid of our progress bars. But since we're not actually going into combat, we do want to keep all of the references and stuff like that. So if we happen to go back to idle, we can pick up where we left off. And so we're going to grab the aware pin over here. And what we're going to do is add a branch, and we're going to set the perceive times to -1. And then we can check in the actors that actually see the sidebars what the perceived time is, and deal with it from there. So we're going to grab a branch, plug it in here. We can grab our perceived times, so the array, and we want to get a copy. We're going to get a copy of the current index from the loop. Oh, over here. So this mouse thing is really an issue. I need to make sure I get my mouse pad in here quickly. So we're going to drag off the current perceived time and check if this is not -1. So if we changed it already or not. So let's do -1, plug it into our branch. And if this is not -1, so if it's true, then we're going to set it to -1. So we're going to grab our perceived times array, drag off here and set an array element. Plug it into the true pin. So the index is the same one as the array from the for loop. And then we want to set the item to -1. And we don't need to enable size to fit because this entry already exists. And after we did this, we need to make sure that we call the update AI awareness on the possessed pawn. So we want to drag off the possessed pawn over here, and then, we want to drag off the actual array element, and we're going to update the AI awareness. So that's the message function from the interface. And in here, we need to plug in the possessed pawn as the perceiving AI. And the perceived time is -1 again. So this will make sure the update actually reaches the player that has been perceived by this AI, and he can handle the correct value as well. Okay, so that's this part, and now we also want to make sure that if our timer actually reaches 5 seconds, so if it's filled up, at that point we want to trigger the aware state again. So that's over here. We're checking the perceived times after we added 0.2 seconds. We have that clamped, and we're updating the awareness. So that's the actual progress bar. And we can simply add a branch in here and check if the current time is equal to our maximum. So we can grab our perceived times array, drag off here and get a copy. So we want to get a copy of the actual array index. So let's just hook it up over here. All of those go back to the array index. And then we can compare that. So let's do is greater than or equal, and simply hook up our maximum perceived time variable. So for me, this is set to 5 seconds, but you can play around with it. So that's going to be the condition. And if this is true, we're going to call our AI change state. So that will trigger the combat, and then make sure that all of the other AI triggers combat as well. Aware. Oh, I'm messing up. So we want to set this to aware. We're not triggering combat. And because we are setting this to aware, we also want to hook up the spotted actor, and that's simply the player from the for each loop. So the array element over here. Okay, so we have that set up. Now we need to make sure that we actually handle this -1 value correctly. So to do that, we need to go to the player AI component again. So in the blueprints folder, player AI component. And in here we have the update awareness function that handles the sidebar. So over here, update awareness. And we can simply make sure that the actual value of the perceived time is greater than 0. So that's the first thing we're going to do before we actually add the actor to the array over here. So let's drag off and look for a branch. And we want to drag off the perceived time and make sure this is greater than 0. Plug it into the condition. So if this is true, we're going to continue to the add unique for the actors and simply do what we used to. And if this is false, then we can hook it up over here on the right side where we are removing the widget component. So we have the node remove widget component, and before that we have a branch that checks if the found index is greater than or equal to 0. So we want to plug it right in here. So we're going to grab this and plug it into the branch that we created into the false bin over here. So that should be good to go. And then this is hooked up to the find node over here. So we do need to make sure that we have a current index set. Otherwise we will not be able to check this over here. So right now, if we follow this line, we are not actually executing the find node that sets the current index. So we need to make sure that we grab this setter and also paste it down here. Hook it up to the find node, and then we can hook it up back to the false bin and the actual branch over here. Okay, so this should be good to go, and this should take care of the progress bar widgets if an AI is aware. So this will only remove the progress bars for players that have been perceived by this AI. Yeah, that should be pretty much it. So if we compile and save, then at this point this should work. So if I walk into the side range, the bar will start filling up. And now if the bar is full, the bar will uh, be removed and the AI will actually move to the location where he last saw me. So that's all we did right now. He's not going to go back to idle, but as I mentioned, we're going to set all of that up in the actual behavior tree. So there's no need to actually worry about that and then get rid of it in the next episode. So we have this set up and that's good to go and working. That was the most important part. And if we walk into the side range with the close side range, currently we have it set up with the game mode, so it should actually get rid of the actual progress bar as well. And that's working. Okay, so I think for now this is a pretty decent cutoff point. As I mentioned, we're going to do the behavior tree in the next episode, so that's a nice switch. And we have some default setup for our stage that we can work with, and we can switch between them. So not the most exciting stuff, but we did make important progress, and I promise you from the next episode things will be a little bit more interesting if you're actually here for the behavior stuff. So then we're actually going to start setting up our behavior tree, Blackboard, and perhaps in the next episode also a little bit of EQS, and otherwise it's going to be the episode after that one. Okay, so thanks for watching everybody, thanks for your patience, and I hope you enjoyed the video. If you did, please consider leaving a like. I'll be back soon for more. Later guys and girls, bye bye.